So yeah, so good morning everybody from wherever you're watching me from. My name still remains Olaniyan Desmond. So we have started our data science classes. Then we will be doing non-pi now. So we are the non-pi data type. So if you follow our curriculum, you will see that we are in non-pi data type. So in the NumPy data types, we have various data types in Python, which you know about. So by default, Python has different data type, which are string. We have string. String. Can you hear my voice? So strings are used to represent text data. That is, the text is given under quotation mark. So something like this, then if you want to do anything about string, you have to use quotation mark like this. Then you cannot write anything you want inside inside it. So write anything in inside it. Then you close your text. Right. So whenever you see any words in quotation mark, so that is called string in Python. So also NumPy also uses these kind of data types as well. So in NumPy we also have something called integer. So integer are used to represent numbers that are without decimal points, which you have been covered in your Python classes. So the integer can be negative number positive or positive number positive number. So whichever one you want. So in as much they are not decimal points, they are either negative or they are either positive. So they are all called integer. So we also have something called float. Float we use float to represent any number that has decimal points. So irrespective of either positive as well or negative, it's also a float. So we also have a boolean data type which is used to represent true or false. Any data type that is true or false is are they a boy, yes or no. That kind of data is a boolean data type. So NumPy also uses this kind of data type. So we also have complex data type which are used to represent complex number. Example, you can have 10 1.0 plus 2.0 j or 1.5 to plus 2.5 j. So the words are attached with a with an alphabet. So this kind of data, or maybe when you say 5x plus 6y is equal to n is equal to n. So this kind of data type is called a complex number. So that is that about NumPy. So let's quickly go to various uh yeah, these are the list of all data types that we have in numbers and their characters used to represent them. So I is represented as integer, B is boolean, U is unsigned integer, F is float, C is for complex float, M is for time delta. So we also have date time, which is M, and O as object, S as string, U as unicorn string, V as fixed chunk of memory for all the data types. So in NumPy, you can also do checking the data type. You can also check um, what is a kind of data type, a particular uh, variable you're working with. So NumPy array object has a property called data types or D types that return the data types of the array. Now let's take an example. Let's try to copy this example one. So let's go to our our code cell downstairs. We paste it here. So let's name this example one. Okay, okay, okay. So definitely we import numpy as np. So we declare a variable called arr. Then we we now represent the this list as an np array. So we now check. So to check the kind of data type this variable is, what you need to do is you do print, then the data, the variable you're trying to check, which is arr, then dot d type. So as we have said earlier, that d type is an a, is a function that we use to check data types. So it will give you the kind of data type your your variables are. So this is what integer 32 bits. So let's also check for another example. Let's check for this example. So the first example is for numeric example. So let's check for this. Let's call this example 2. What did you say? So you did a mistake. Check where you did a mistake. So remove that data type. Yeah, yeah, remove it. Everything about that data type. Yeah, I'll remove it. So, yes, remove that comma. Run it. It's gonna work now. Yeah, yes. So um, so we have another example here, example 2, which contain a strings. So definitely we import numpy as np. So we represent it with a variable called arr. Now our np array. So we store this list of fruits into an np array, which everything is now stored into this variable called arr. So if we want to check the kind of data type this arr is carrying, we do print arr data type. So you come to this place, this button, display button, you do run. Okay, so it's giving me um error because of this example 2 that I put here. I supposed to make it a comment. So how do you make it a comment? You put hash before it. Can you see? Immediately I put hash before the example 2, the color changes and it has turned to comment. So if you now run this again, if you run this cell again, we should. Oh, okay. We also have another string which we need to turn them to a comment because you are not using it in the code. So I'm just trying to let you know that this data types is an array containing strings. So we run this code again to see this kind of example, and then we have our data type as what u6. So let's go to the list and see what is u. U is what? A unicorn string. So u is a Unicode string. So this tells you that this type of data type is a what? Is a string. So that is that about how to check the kind of data type you are using. So another thing we're going to check is um, what if let's say, okay, let's say Okay. Uh, we want to do creating arrays with a defined data type. Yeah, so we want to do that, creating an array with a data type. So what does that mean? Creating an array with what? A defined data type. So we use array function to create an array, right? As we have said earlier, that we use array function to create an array. So this function can take an optional argument, which can be data types, that allows us to define the expected data type of the array element. For example, let's take this example. Um, let's see. Let's see. For example, let's create this. Okay, let's create this example. Let's see what this will give you. So this should be, you have to convert it to string, to comment rather. So, and this, let's make it a comment. That means you want to create an array with the data type string. We import a number as np. We declare a variable arr. So we have a list of um of numbers. So wait. So we have a list of numbers. Then we now want to create an array with the data type string. We want to make sure that this thing is represented as what? As a string. So that's why we put d type s, which s, yeah, in our list, yeah, s means what? String. S means string, yeah. So s means string. So if we print let's comment this print out. So let's run it. You can use shift and enter to run the code, or you can also run the code here. You see, when we run the code, so it now printed our results out like this. So we now have various representation. So we have successfully converted these numbers to string. Can you see? It was numeric before. Now it is now in string. Do you have any question? Okay. Okay. Yeah. So you have to check it again and run it again. Hmm? So recheck it and rerun the code. You should go to create a new, create a new one. So it should run. So the, yes, just create a new one there. So you can copy the code from our notebook. Yeah. So you can get it. So let me continue why he's doing his work. Where are we? So we are creating an array with data type. So we have, so let's even check the kind of data type this thing is. So let's run this again. So we see that it is in a what? Si. So, and what is si? What is the meaning of xi? S means string, right? So it now tells us that this particular numeric or integers has been converted to string. So that is that about that. So let's so we will be going to our next project, which is what our next topic, which is what uh numpy numpy array numpy array copy versus view. So, and we're going to turn this to a markdown because this is in a code cell. So how do you turn this cell to a markdown? You come here, can you see it's in a code? You double down, you click markdown, and this will turn to markdown. So you run it, you click run, boom, it has turned to what? Yeah. So our topic now is, hold on, let me answer this question so that we can continue. So welcome back to this topic. I quickly answered um question. So from our life students, so I'm back to the topic. So we are on a new topic, which is what numpy array copy versus view. So we want to know what is numpy array copy, what is numpy array view, why is numpy array copy different from view, is there even any difference between numpy copy versus numpy view. So yes, there are differences between numpy copy and numpy view. But the main difference between a copy and a view of an array is that the copy is a new array. Should I come again? If you copy, if you use the copy function of numpy, that means that is a new array, and the view is just a view of the original array. If you have an array earlier, you want to view it, you want to see it, you will use the view function in NumPy. But if you're creating a new array, you have to use the copy function. So that is the two differences between copy and view. So if you're creating a new NumPy array, you use copy function. Then if you're trying to see the previous ones that you have done, you can use the view. So the copy owns the data, and any changes you make to the copy will not affect the original array. So this is also one of the functions. So if you do a copy, it will not really affect the original one that you have, and any changes that you make to the original array will not affect the new array that you have done. So the view does not own the data, and any changes made to the view will affect the original array, and any changes you make to the original array will affect the view. That is the way both copy and view are different. So let's even see an example of how we can use numpy copy, numpy view. So example one, example one, example one. So we will still import our numpy. Thank you. So we will still import our numpy. So we do import import numpy as np, import numpy as np. Then we create a variable called, what variable should we use? Yeah, let's use the variable called Remy. A variable called Remy is equal to np.array, which is our function to represent anything in an array format in NumPy, right? I don't know why this thing is doing like that. So we need a bracket, open and close bracket. So inside the bracket we need a list, and you know that a list if you want to do a list, you have to use the square bracket. So let's do a list of 1 to 5. 1, 2, 3, 4, 5, right? Then let's now, we want to use the copy function, right? So let's now do x is equal to, what is the variable name, which is Remy dot copy. So, and I told you earlier that if you use copy means you want to create a new array, a new numpy array. If you use the copy, you want to create a new numpy array. So whatever you do in the copy does not affect the original one, right? So let's see how it works now. So we are now creating another variable called x, which we are representing this variable Remy dot copy function. Then we'll now do Remy. Then we want to add a new we want to add 10 to this number. Initially we have 1, 2, 3, 4, 5, right? So now we want to add 10 to it. How do we add 10? Then we'll not do Remy 10 um 10, let's say equal to 34. So let's now print um Remy. Sorry, you have to print Remy inside. Let's print Remy first. Let's see what Remy will tell me. Okay. The index 10 is out of band for axis 0 with size 5. So what that means is that you cannot put a number that is greater than this axis. Did you get the point? You cannot put number that is greater than this axis. So what number do you feel that we can put that is not in this axis? Let's put 0 because 0 is not there, right? So let's do 0. So let's run it again. Let's see if okay. Now, can you see? Okay. So what this means is that we use the copy function in array to put in a new value, which is 34, right, into this existing list. So we now, what this code means is that we want to copy is used to put a new um item into an array. So we now specified where will this item be placed, and in your numpy, this one eh, is what is index of what 0. This 2 is index of 1. This 3 is index of 2. This 4 is index of 3. This 5 is index of what 4. So so you can now see that what we did was we now added a new number, which is 34, into our list. But where do we add it? We add it at the index 0, which is here. So that means if we remove this one and replace it with 34, that's why we have 34, 2, 3, 4, and 5. So let's now even now print x. Let's see, print x. Let's see what x will give you. So if you do run, so can you now see? So x now give you what? The original value. Can you see what we are trying to say? That once you use copy, if you use copy and you make any change, it will only affect it will only affect the new array, but um leave the previous numpy as it is. So if you use copy, any changes you make to the copy will not affect the original. So this is a typical example of it. So the original array is what? 1, 2, 3, 4, 5, right? So you will now make changes to the original one, which is what? 34, 2, 3, 4, 5. But the original one is still there. So any changes you make to the original array will not affect the original array. So if you use the copy, so that's the different. But if you use the view, eh, any changes you make to the view, it will affect the original array, and any changes you make to the original array will affect the view. So let's quickly make an example of a view using this same code base. So let's make this one example two. So we still use Remy, then we still use so instead of us using copy, we use view. So we will now see. So if you save it and run it, can you see? If you save it and run it, can you see? So the changes that we make now affect the even the new array and the original array. That is the difference between numpy array copy and numpy array views. So if you have any question, you can let me know so that we can continue. So our next topic is numpy array shape. Numpy array shape. So numpy array shape. Sorry. So let me convert this to string. So let me do so let me run it. So numpy array shape. So we're talking about the shape of an array. So the shape of an array is the number of elements in each dimension. The shape the shape of an array is the element. I need that is the element of the shape of an array is the number of elements in each dimension. Rather. So the shape of an array is the number of number of element number of elements in each dimension. So how do you now get the shape of an array? To get the shape of an array, NumPy array have an attribute called shape. It has an attribute called shape that returns a tuple with each index having the number of corresponding elements. So let's take an example. For example, let's do an array of let's do an array. Let's copy this array, this previous array. Let's copy it. Let's put it there. The previous array, Remy, np.array. So to now check, let's add more numbers to it. 50, 79, 34, 56. So this is an array, right? A list of numbers. So store as an IP array saved in Remy variable. So if you want to get the shape of this array, all you need to do is you use print function in array in print function in Python in NumPy. Then you call your variable name, which is what? Remy dot shape. So if you use Remy dot shape, can you see? It tells you that this is a number, the list of numbers that contains what, nine figures. So one, two, three, four, five, six, seven, eight, nine. So a shape of an array is the number of elements in each dimension. So if you count this, there are also nine. So that one is simple. So um that one is very, very simple. So you can also check the documentation for more examples. So and uh we are also doing numpy array reshaping. What is numpy array reshape? So all of these things are useful for you when you want to start doing your data science. So that's why we are more emphasizing on you making having the knowledge. So what is reshaping a numpy array? Reshaping just means changing the shape of an array. And I told you earlier that a shape of an array means just you want to know the numbers of elements in each dimension, right? So y- how you can now change the dimension of that array is what we refer to as numpy array shaping. So the shape of an array is the number of elements in each dimension, which I've said earlier. So, but by reshaping, we can add or remove any dimension or change any number of elements in each dimension. So that means you can remove any number, you can also add any number to it. We talked about shape, copy, and view. Yeah, but this we will use the reshape function in NumPy. So let's still use this um example. So we do this example. So we now want to put in um add in a new number. So what you need to do is to create a new variable. So you can give it any name. Let's call it seat as our new variable. Seat equal to what's our previous variable name, which is remilekun. Dot you use the reshape function in NumPy. So remi dot what reshape, remi dot reshape. So you will now put the numbers that you want to add to the list. What number do you want to add to the list? Let's put 105,767. So what you will now do is to print the new variable name, which is what, sit. If you print it, you run it. Okay. It says cannot reshape array of size 9 into 156. So what that means is that if you want to change the shape of these elements, it must have to follow a matrix function, a matrix away. So that can have maybe three rows, three columns, four rows, four columns. So it is that dimension that you will put in this reshape. I deliberately put it here so that you can see this error, so that you will know that whatever you need to put here is the matrix dimension that you want to reshape these things to. So let's reshape this variable to, let's say, um 4 by no 2 by 3 dimension, matrix dimension. So it will be 2 by 3 dimensions. So if I run it again, can you say it says cannot reshape an array of size 9 into 2 by 3 dimension? Why? Because if you count our numbers, what's our numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count it, that means the items here are what? Are 9. Then if you want to reshape these nine items into 2 by 3, will it be able? So that means you are saying it should be what? Two rows. Um uh is it 2 rows and 3 columns, right? So let's even do 3 3. Let's see if it will run. Okay, now it ran. So the reason 3 rows, 3 columns run is because the number of items in this place is what? They are 9. If you count them, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means three three columns, 3 rows, 3 columns. So these are roll over. The first roll is what? 1, 2, 3. So the second roll is what? 4, 5, 50. Then the third roll is what? 79, 34, 56. So that is roll. So our column is what? 1, 4, 79, 2, 5, 34, 3, 50, 56. So you can only reshape the list into a dimension that can fit in. Did you get the point? Now, if you change this one to 2 2, let's see if it will go. Like if you change this dimension, I'm coming. Let me return it. So let me copy it and put it into another one, another example. So that so let me change this into 2 dimensions, 2 row, 2 column. Let me see if it will run like that. If you press run, you will get error because there are 9 and they cannot be reshaped into 2 rows and 2 columns, because 2 rows and 2 columns is that this one will be what? 1 and 2 and 3 and 4. So where will it now keep 5, 50, 9, 59, 34, 56? But if you add one more one more numbers, let's say 12. Yeah, so the whole number should not be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10, right? So that means you can now divide 2 by 10, which is what? 5. So you can now have two 5 rows. You can now have 5 rows, 2 columns. So if you run this, okay, so it is, let's do it as 2 by 5. So if you do 2 by 5, if you run it, oh, is this still 9? Oh, sorry. I went to go and include it here. I went to include it here, which is supposed to be here. So let's put our 12 here. Sorry about that. So let's put our 12 here. So and let's still do, let's first try 5 by 2. 5 by 2. So let's run it if it will run. Okay. So it is what? 5 rows, 2 columns. So the way we say it is that the first one is the row, while the second one is the column matrix. So that means we are converting this list of numbers into 5 rows and into 5 by 2 matrices. So if you do not know matrices in your school, I think this is the time you need to revisit it. So this is 5 rows and 2 columns, which is, this one is row one, row two, row three, row four, row five, which is what? 5 row and 2 columns, which means this one is a column one. That means 1, 3, 5, 79, 56 is one column, and the other one is 2, 4, 50, 34, 12 is another column. So you can reshape from um, one dimension to two dimension if you like, and you can reshape from one dimension to three dimension if you like, but depending on the list numbers of elements of list that you have. And at the same time, you can do um numpy array iteration. So let's do numpy. Let's go to the next topic, which is what? Numpy array iteration. Numpy array iteration. So after we are done with this up to the array filter, we will call this class a day. So numpy array iteration. Let me change this to a markdown format. So I run it. Okay, my numpy is not correct. My numpy. So the edit is this. Numpy running again. Sorry, sorry. My numpy array iteration. You run it, it gives you this. So what is numpy array iteration? It means once what is when you are iterating over when you are iterating over a particular thing. So um, that was we call a numpy array iteration. That is, you are trying to iterate an array, a numpy array. So what is the real meaning of um iteration? Lock that door. So iterating means going through an element one by one. Iterating means going through an element one by one. So for example, if we have this array, so iteration means there will be a function, either a for loop or a while loop, that will go into this list, and each time it comes into this list, it returns the value and go back again. It will see another list and return the value, go back, and it will start going back and forth until it gets to the last, and go, it goes back again, and when it cannot find anything, it end the loop. So that is the way iteration means. Iteration means going through an element one after the other until there is nothing left in the element. So as we deal with multi-dimensional arrays in NumPy, we can do this NumPy array iteration for using a for loop that we have learned in our Python. So you see how Python is connected to NumPy, that it is necessary that you start your foundation from Python, then later you can now start progressing using NumPy, using pandas, using matplotlib, using Seaborn. Then before we now start going into the deep into data science itself. So all of these things are what you will be needing as your journey progresses in data science. So if we want, for example, if we want to iterate on a one-dimensional array, it will go through the it will go through each element one by one. Let's take an example so you know what we are talking about. So let me still use this Remy example. So copy it from there, you paste it here. Then let's now write a for loop that will iterate over this list. So how do you create a for loop? In our Python, to create a for loop, you use for. So for x in dash. So that means for what do we want to use to represent our messenger? Let's call our messenger X, or let's call our messenger Lekon. So for Lekon, mind you, Lekon can be any name, can be anything you like. That's why we are putting this name Lekon as our messenger that we will send into this Remy to help us look into this list. So each time Lekon gets into this list, once it sees one, it will return it and write one. So Lekon will go back into this list. You know, after it has removed one, there will not be one there. So it will see two. it will return 2. Then Lekon will also go back. It will see 3, it will return 3. Lekon will go back, it will see 4, it will return 4. It will go back again, see 5, it will return 5. So that is the way Lekon will do until Lekon reach 12 and return 12. So when Lekon now goes back and did not see any number, Lekon will now end that assignment. So that is the meaning of iteration in even in Python and in NumPy. So for Lekon, in where are we sending Lekon to go and iterate for us? We are sending Lekon to iterate in Remi. That's why we write for Lekon in Remi. For Lekon in Remi, make sure that this thing, this spelling is the same thing as this spelling, so that you will not have error. For Lekon in Remi, then you do a semicolon, then you press enter, then you print. So our instruction is now to print what? To print whatever Lekon sees in the loop. So if you click run, you will see that it has done it. So this is the output that Lekon brought. So what it means is that each time Lekon goes into this list, hmm, so can you see? So you will get this notebook later. So each time Lekon goes into this list, you will see one, he will return it. He goes back, he sees two, he return it. That's the way he goes until it reach 12. Then it goes back again. So when he did not see any number again, so Lekon ended the loop. So this is a basic iteration in NumPy. And as well, you can also iterate a, a two-dimensional array. So this is a one-dimensional array. So let's iterate a two-dimensional array. So what you can do in two-dimensional array is to, let's use this hold on hold on. So if you have question, I said you can let me know so that I can answer you correctly. So let me quickly pause this video so I can answer the question. Then we'll come back and explain um iteration of NumPy in two dimension. So please hold on. Let me pause. Okay, now we are back. So we are trying to do a an iteration rather of a two-dimensional space. So in NumPy. So we said that to do a a two dimension, the number of rows must be equal to the number of columns, and the first dimension must be the same thing as the second dimension. But if we do this, we will not be able to do it. That means our code will be an error. So let's convert. Let's count it. How many are these? Um, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see. So and if you want to do a two dimension, you know that it must have um the number of rows and the number of columns of the first one must be the same thing as the number of rows and number of columns for the second one. So let's do a two dimension. So let's do 1, 2, 3. Let's do this as what? As a list, comma. So this is one dimension, comma. So let's do 4, 5, and 50 as another dimension. So let's clear this out. So let's use this example. So let's use this example as our two dimension. So if you run this, you will see that it also loop through and give us the first dimension is what 1, 2, 3. The second one is what 4, 5, and 50. So it's still the same way that you can use for three dimensions as well. Um, that's the same things to that you can use. So yeah, I think we need to go to the next one. We need to go to the next um the next thing that we're going to talk on, which is array, numpy array joining or joining numpy array. So yeah, numpy joining array, numpy joining array. Is my joining correct? Yes. So let's turn it to Markdown. Let's run it. So numpy joining array. So what is numpy joining array? Joining means putting content of two or more arrays into a single array. Let me come again so you can hear me. For those of you, I hope you can hear me now. Okay. So joining joining of numpy arrays means the word the word joining itself means you putting content of two or more arrays into a single array. For example, in SQL, we can join tables based on key. So whereas in NumPy, we join arrays by axis. So we pass a sequence of arrays that we want to join to the concatenate function along with the axis, right? So if the axis is not explicitly passed, it has to take it has taken a zero value. So let's see how we can join two arrays. So we first of all declare the first array, which was array one, equal to numpy dot array, numpy dot array, numpy dot array. Definitely, we have to create a list. Let's do 1, 2, 3, cover it, then close the bracket. That is one one array. So let's do array two, arr2, which is our second array. So we do numpy dot array. Yep, yep. So let's do 4, 5, 6. So how do you now do joining? Numpy joining in this. So what you can do, we said that you can use concatenation to join two arrays together. That means you want to join array one plus array two together to become one complete array. So how you can do it is, let's declare another variable called um, join join array. Let's just do join array as our variable name, which will be equal to we use np.concatenate np.concat np.concatenate. So what do we want to concatenate? We want to concatenate um we want to concatenate this variable one and this variable two together as one. So what you're gonna do is you're gonna do create another bracket. So inside you do array arr1 comma arr1 comma arr2. So and after you've done this is the function that will join this first array to the second array. So what you need to do is just to print. So which one are we going to print? So we print this our new variable, which is what? Join underscore array. Join underscore array. So you make sure that this word is the same thing as this word, so that you will not have error. So once you run it, can you see now we have successfully combined this plus this together, giving us this. So that is how we are able to join numpy arrays together in in numpy. So if you check the document, you can see various other examples that you can use to join arrays. So let's do another one, which is numpy splitting array. So numpy numpy splitting numpy splitting array. Numpy splitting array. So let's turn it to a markdown. So let's run this. Uh, Let me do numpy. So let me run it. What did you say? Okay. So now, how do we split arrays that we have joined? In this example, we were able to join this first array plus this second array. We were able to use this function np concatenate to join them together to become one. So how do we now split them? So what is splitting in NumPy? Splitting is the reverse operation of joining. As you know, that if you join, you can also divide. So splitting is you dividing it. So how do you divide an array that has already been joined, or that is even just only one? How do you split them? So we can use the array split function to split them. So let's quickly take an example. Um, let's call our variable. Let's do our variable as. Let's copy this one. ARR. Let's remove this one. So let's add other numbers. Give me numbers. Yeah, you have added one. Okay, let's do 20. One numbers. 29. One numbers. 99. Oh, okay. One number. Huh? 6. So 99, 6. So we want to split this particular array. We want to split them into how many parts? So you will now decide how many parts you want to split them. But before you split, you have to count if you can actually split this number into equal parts. So for example, how many values do we have in this array? We have one, two, we have three, we have four, we have five, we have six, we have seven. So we cannot split this array into any number because it is 7. So maybe we can add one to it to make it 8. So we can either split it into 2, or we can split it into 4. So it has to be even before we can be able to split it. So once it is in odd numbers, we will not be able to split it. So this one is 7 characters. 1, 2, 3, 4, 5, 6, 7, which will not work. So let's add one more. Let's do 9. No, let's do 7. So let's now split it into 2. So to do that, we will now create a new variable. We call it new ARR, which will be equal to np np. We said our splitting function is array split. splitter, sorry, array splitter, array split rather, array split. So what do you want to split? The variable called ARR. So how many do you want to split it to? You want to split it into two. So you now do print. You print your new variable, which is what? Newarr. So if you do run, or you say split is not defined. So it is pointing us here. Why? Because we use hyphen instead of what? Underscore. So let's run this and let's see. Okay, we have a spelling error here because we do new ARR here, then we now do new MARR here. So I said that we should be very careful when we are writing in Python so as to avoid typographical error, because it will throw you this kind of error. And luckily for you, you know where your error lies, which is this. So if you run it, I've made the changes, which is NEWARR, NEWARR. So if you run this, it should give you a two different splits of your what? Of your non-pi. So this is that about non-pi splitting. So you have the material, so you can do your further examples. So we are in NumPy session. Yes, after this you are gone. You are done. So let's do the second to the last one, which is what? NumPy searching array. So how do we search? How do we search for particular things in an array? Yeah, let's change this to a markdown and let's run this. So we have this. So searching arrays. So what does this mean? So you can search an array for a certain value and also return the indexes that gets a match. So to search an array, you use the function where, or a method called where. So let's quickly do one example so we can um let me still use this example. So we'll just make some modification. So we have a variable called ARR. Then it is an array which we put, and we have variables, numbers, a list. So now to now use the where method, we have to declare another new variable which we now have our where method here instead of array. So we do where. So this one is, you do the list, that means the previous variable. So you want to do it to where, to for, then you do print. So let's see what it will give us. Okay, now we have the array. So let's change this figure. Let's change these figures to 1 2 3 4. Let's change it to 1 2 3 4. Then let's do 5. Let's do 4. Let's do 4. So let's change this 1 to 4. Let's see what it will give us. Can you see? So now we now have what? 3 5 6. So that means you are trying to search where, how many times this 4 appears in this array. So if you go by index, this one is what? 0. This one is what? 1. This one is what? 2. This one is 3. So our first 4 appears where? On the 3 index, right? This is it. Then it goes again. This one is 4. This one is 5. So our second 4 appears where? On the fifth index. So, and this one is 6. It appears on the sixth index. So the searching array is used to search which index this particular number falls to in the list of an what NP array. So you can also try other examples and see for yourself in the documentation that we have. So we have our second to the last example, which is what NP sorting array. NumPy NumPy sorting array. So how do we sort? How do we sort? How do we sort in NumPy? So how do we sort in NumPy? So what is sorting? Hurry up. What is sorting? So sorting in NumPy means you want to start checking one or two things you want to arrange. Let's do sorting means putting an element into an order sequence. What that means is that you want to place things maybe in an ascending order or descending order. So you want to put a particular list in an order of sequence. So order sequence in any sequence that has an order corresponding to the element, like a numeric or alphabetical order or ascending order or descending order. So NumPy ending array object has a function called sort. So you can sort any kind of array. Let's take for example, let's take this variable arr. So let's sort it as so let's use our sort function, which is what print np dot sort. Np dot sort is the method that you're going to use. So what do you want to sort? The variable called arr. You have to close this one, then you have to close the outer one. Then if you run it, it gives you error, which was the module numpy has no attribute spot. Please, is it spot that we say or sort? That's why I say that you must be very careful of what typographical error. So we remove our p and run it again, then we have our answer. So this has ordered this list from ascending order, right? So that is that. So you can sort any kind of you can sort any kind of array. It can be numbers and it can also be um, a list of alphabets, like a string. Let me put it that way. So let's do an example of a string. An example of a string. You have used um, number integer as an example. So let's do string. Let's do banana. So banana as the first one, comma. So let's do another fruit name, which is what? Mango. Mango. Then let's do another one, which is what? Um, cherry. Cherry. So if you do sort, this will sort it alphabetically. So if you run this, you will see that B comes first before C, right? So you sorted them alphabetically. So that is the end for that. So let's touch our final example for this class today, which is what NumPy filter. NumPy filter. NumPy filter array. So let's change it to Markdown. Let's convert it to Markdown and let's run it. So what is filtering? Filtering in NumPy means getting some elements out of an existing array and creating a new array out of them is called filtering. You get some elements out of an existing arrays, then you create a new array out of them. In NumPy, you filter an array using the Boolean index list. So if the value of an index is true, that element is contained in a filtered array. Now, if the value at that index is false, that element is excluded from the filtered array. So let me even do an example so that you know what I'm talking about. So let's do a a variable called array equal to np.array np.array. Let's close the bracket. So let's do a list. What list should we put? We put 41, 40, 41, 41, comma 42, comma 43, comma 44, right? So let's now do the filtering. Now let's create a variable called x. X will be equal to, let's do a list of, so true, false, or false, true, whichever one. True, let's do true, false, true, false, true, true, false, true, false. So let's now do a new array, a variable called a new variable which called new array, which will be equal to our previous our variable, which is arr. Then let's do um uh, x, which are our one, our this this x here, a variable that we declare true, false. Then we do print uh our new our new variable arr. Then if you run it, you will see that it gives us what, 41 and what, 43. So which is trying to filter if this one is true, this one is false, this one is true, this one is false. So it give us only true. It give us only true. So 41 is true. That's why I give 41. 43 is true. That's why I give you only what, 41 and 43. So you can try other examples. So this has come to what we have discussed earlier. So we have talked about numpy filtering, talked about sorting, searching, splitting, joining, array iteration, array reshaping, numpy array copy versus view. Then um we have talked about numpy data type. So this brings us to the end of this class for today. So we will continue um our our other aspect of numpy maybe next time, which is numpy random, then numpy u function. So see you in next class. Bye.